Good evening, class. So before I dive into today's lesson, I just want to say, Dr. Nolasco, did you do something to your hair? There's something different about you, but it looks fantastic. Just wanted to point that out. So without further ado, for today's mini lesson, we will be focusing on the Common Core standard using functions to model relationships between quantities, and the target grade level is 8th grade, and this would be for an algebra course. So we will be examining a function and components of a linear relationship between two quantities. Then we will look at rate of change and initial value of a function. And if time allows it, we will go ahead and look at a table and a graph so we can learn how to take apart the x and y value, which we will come to learn can also be called the independent and dependent variable, also known as input and output. So first, what the function? What is a function, right? Let's put the fun in function. A function is a relation between a set of inputs, also known as independent variable, and outputs, also known as dependent variable. So it's important to know that the independent variable is ultimately what's gonna produce our dependent variable, because it's dependent on the independent variable. And input and independent and output and dependent can be used interchangeably. So here I have a graph. We have our x axis here, and we have our y axis here. I'm sure you guys are familiar with that if you guys have taken high school math, any high school math class, which I'm sure you all have, because you guys all seem like brilliant students. And in our y-axis, we have calories, and in our x-axis, we have time. So I just thought of a relationship that I can model. It's about to be Christmas time, New Year's. People have New Year's resolutions. For a lot of people, it's doing more exercise or, getting that body that they want, whether it's through Peloton or through Zumba, LA Fitness, you name it. I know it's a popular one, so we're going to go ahead and go with that. So, as you can see, the x represents the independent variable, and the y represents our dependent variable. And the blue line here represents the linear relationship, hence the line. And basically, the more time that we spend at the gym, if there is a constant rate of change, which there should be for a linear function, then the more calories we will burn. In theory, assuming this is a perfect exercise and we're not stopping to change a song or chatting and whatnot. So as you can see here, I've added some more information, and I will be covering each element separately. So first, let's focus on the graph here. As you can see, I have added increments of 5 on the x-axis, which represents time, which is our independent variable, also known as our input. So I have added increments of 5, basically representing minutes. So, right, because 5 hours, that's a bit intense. Maybe Dwayne Johnson could do that, but not us normal folks. So for every 5 minutes, because we have 5, 10, 15. If we follow this graph, it represents that for every 5 minutes, we will be burning 3 calories, as represented by our y-axis, also known as our dependent variable, or pop quiz. What is the other term we can use for that? Okay, so now moving on to this function. You may be familiar with this, f of x equals mx plus b. It may look familiar to you if you are familiar with the slope-intercept form. We have just replaced the y with the f of x, and that is to represent the output, which just shows us that whatever we do with the input of x, it's going to directly affect the output. And you can kind of think of it as a machine, and whatever goes, so the input here is x, right? And we're going to put it in the machine. So x is just a placeholder, and so that says function, okay? Yeah, that says function. So whatever value we use for x as our input, it's going to go in the machine, go in the function, and guess what? Out comes our output. So that's one easy way to remember it. Now I know it's getting real messy here, but it's controlled chaos, so just stick with me. All right, so now we're going to look at our slope, which we can see is in the orange writing. The slope, which is represented by m, as we can see here, is just rise over run, or the change in y over the change in x. So if we're looking at our graph, we can see that the change in the y from 3 to 6 is 3, right? 6 minus 3, that gives us 3. So we're going to write 3. And actually, I'm going to go ahead and use the same orange if I can find it. There you go. So we're going to use 3 over a change in x where we have 5 and 10. And we can see that the difference there is 5. So that is our slope, the change in y over the change in x. So here in this function, which represents this graph, we would replace that m with 3 over 5. So we will have f of x is equal to 3 over 5. And x will just represent the input, which right now is being represented by the time, so how much time is being spent exercising. And then we have plus 0, because the 0 is representing the y-intercept, which we can see over here on our right. And our y-intercept comes from, and I'm sure some of you already know this, especially my mathematicians, but the y-intercept comes from where our line here, our graph, on our graph, where it crosses through the y-axis, which here is calories and runs vertically. So as you can see, our graph here runs through the y-axis, or intercepts our y-axis right at the origin, which is 0, 0. So let's say this line here was right there instead. Then because our graph here crosses through the y-axis at 3, then that 0 would become a 3. But that's not the case here for our graph. it crosses through 0, so that's where we get the 0 from. All right, now that we have our function, f of x is equal to 3 over 5x plus 0, we can go ahead and play with this function and use different values for our independent variable, or our input, which is x. And we'll just go ahead and do that. Just off the top of my head, let's say we spend 15 minutes at the gym or doing exercise wherever. Then I'm going to go ahead and replace that x value with the 15 is equal to 3 over 5 times 15. And I'm just going to leave the 0 out of it because it's not going to influence our output or our answer anyway. So if you go ahead and either crunch those numbers in your brain, if you are a math prodigy, you should get 9, right? So if you did it correct, you should get 9. So 9 would be our output. And so then our function would look like this. 15. And then we can put the plus 0 if we want. We don't really need it, but we'll just go ahead and put it there. And so this tells me that if I spend 15 minutes exercising, then I will have burnt 9 calories. And of course, these are just hypothetical numbers. I hope nobody's only burning 9 calories after exercising for 15 minutes, although it feels that way sometimes. Now in this here equation, our rate of change is being represented by slope, which is m, and that is 3 over 5. And it's not always going to be a fraction, but in our scenario, in our case, it was. And the initial value, which is going to be the y-intercept, is 0. So that is our initial value. And just another important detail, if we connect our dots here, we can see that our slope is a straight line and it's going up. So when it's going up like this, that means that it's a positive slope. But that's not always the case. We can also have negative slopes, which you could think of as going downhill. And for the sake of this lesson, those are the only two we really need to get into. So let's go ahead and practice our knowledge that we just gained. Now, if our input is, let's see, I think 40 minutes is about a good amount of time to exercise about each day. So let's say for this workout session, you worked out for 40 minutes. Go ahead and plug it in to our function and let me know. Well, actually, yeah, we're going to replace that x and this x. But really, let's focus more on this x because this here is going to be our output. So go ahead and plug that in and let me know what you get as your output, aka the number of calories burned. here we are going to construct a function based off this table. We will also interpret the rate of change and the initial value of the linear function. So Zippity Doodah was just recently dumped and wants to get in the best shape of his life. The amount of calories he can burn based on his time exercising is shown in the table below. So first we want to verify whether it's actually a linear relationship. And we do that by getting the change in y over the change in x, which, if you can recall, is our slope represented by rise over run. So let's get that out the way. All right. So our change should be constant in both the y value and the x value. So we're going to go ahead and check out the difference in these y values. So the difference between 10 and 5, 10 minus 5 gives us 5. So that's a change in y. And here on the other side, which let's recall that would be our independent variable, because based on how much time we exercise, that's going to determine how many calories we burn. So looking here at our input again, we have 0 and 3. So 3 minus 0 is just 3. And we can do these other values as well. And you will see that we get a change of 5 in the numerator and another 3 over here for the denominator, again for the change in the x values. So why does a change in y values over the change in x values matter? Because that is our slope. And in order for us to write this function, we need to have the slope. So let's recall we have f of x, and then we have our slope that we have determined is 5 over 3. Once again, we have x, which represents our independent value and our input, plus, and here we have our y-intercept. And I want to give you all a second to see if you guys can figure out the y-intercept from this table. All right, so if you guessed 5, then you are correct. And we know this because the x value is 0. So therefore, if we had a graph, the 5 on the y-axis would, let's say it's here. This would be where our graph, our linear graph, crosses through the y-axis. So we did it, y'all. We have our function that models this relationship. Now we can go ahead and test it by placing a value in the x place. So let's go ahead and do half an hour. So we're gonna go ahead, and it would probably appear like that on your math textbook or wherever you see it. It's typically gonna appear like that, f of 30, and all that means is you replace the x's with that 30. So let's go ahead and do that. If you calculated correctly, you should have gotten a decimal. We'll just go ahead and round it to 55 since the number is so close to the number 55 anyway. So this function just tells us that if we were to have exercise for 30 minutes, we would have burnt 55 calories. So once again, input would be 30 and our output would then be 55. Now on to the rate of change. The rate of change, once again, it's represented by our slope. So it would be 5/3, and it is constant, as we already verified. So we have confirmed that it is indeed a linear function, and it would create a linear graph if we were to graph it. Now our initial value is the same as our y-intercept. So when our x value is 0, then whatever y value we have, that will be our initial value, which in this case is 5. Just to recap, we have gone over using functions to model relationships between quantities, constructing a function to model a linear relationship between quantities, and determining the rate of change and initial value of a function from a relationship, including reading these from a table and a graph. So that is all, folks. Thank you for your time. I hope you walk away smarter than when you began this lesson, and take care.